All right, guys. So today we're going to start with a new lecture. And now what we'll do is we're going to start relating the polar accelerations, right, with the forces that are subject to objects that are, going on cylindrical coordinates, etc. Okay, so to recap, this is if I have basically a collar, right? If I have like a tube like that, all right, and I have a collar on that tube, okay. So basically, what we discussed last time is that we now have the ability to find, the radial acceleration and the transverse acceleration, right, along the theta direction. So if this guy is my r and this guy is my theta, okay, and this guy is my r, what do you think are the accelerations that are going to be subject on this block? What are the accelerations that this block will be subject to? We have two, we discussed, right? We have two accelerations. We have the first one is going to be along the radial direction, right? And we said this guy is going to be r double dot minus r theta prime square. And we also have one more acceleration, which is in the transverse direction. And it's not really tangent to this curve, right? It's actually more like, more like this. So it's simply just perpendicular to r, and it's not even tangent, right? And do you guys remember what that acceleration is? Right, so this acceleration is going to be equal to r theta double dot plus 2r prime theta prime, right? And that is our transverse acceleration. What we are going to do in this today is we are basically going to relate these accelerations, right, to the forces that we have. So what do you think are the forces that are going to be subject on the sky? So if I have a collar like that, and I'm going to basically, kind of draw it in this configuration here. So the forces that are going to be subject on this guy is we have two forces, right? We have a normal force, which is actually perpendicular to the tangent. It's not radial, it's perpendicular to the tangent, right? So I have a normal force that is applied on here, right? And what I could do is I could actually have a frictional force, right? And the frictional force is actually perpendicular to n. Okay, so that is my frictional force. Maybe I can even draw it in a more extreme case so we can all see it well. So if I actually have it like that, I have a collar like this, right? And this is my radial line, okay? So I have an object that is actually going along this tube, okay? This is my R and this is my theta. If I want to look into the forces that are here, right? So we have two forces, right? In terms of reaction forces between the collar and then the tube, right? We have a normal force, all right? So the normal force is what? Is perpendicular to the tangent. So this is my tangent right here. All right. So normal force is perpendicular to the tangent. And then we have what? We have a frictional force or a pushing force. So force could be either pushing this guy or it could be decelerating it, right? So this would be, I can call that, for example, P. All right. So this is my N and this is my P. These are the external forces. Obviously, if I have gravity, I would simply put that arrow down like as gravity. But now if I actually want to see the accelerations here or MA, because we've been doing this, right? So here we put the external forces. And then here we put what? The inertial forces. Okay. How would the inertial forces look like? So let me redraw this guy like this. And this is my R. Okay. So what are the two
بس
components?
شو هي البي؟ شو هي البي؟
P is a force, is simply just one more force that is acting along the tangent. It could either be like a frictional force or it could be a force that is pushing, right? So we would have two forces. Now we're talking, in general, right? We have two forces that
ما
could be
فيها تكون
applied.
بي اند اف؟ فيها تكون بي اند اف؟
I'm sorry?
ما فيها تكون انه في فورس عم يدفشها وفي فورس عم يهديها، انه الاف عم يهديها؟
Yep. Ultimately, you have one net force, right? Or P minus F, whatever it is. Ultimately, you can solve for one force. ما هيك نحن هون we have one force in that direction. and we're gonna have an acceleration here, right? And then so basically we have two forces, and then we have two equations, so we can solve for either the two forces if we have the accelerations, right? Or if we have the forces, we can solve that. Or if we have the acceleration, we can solve for the forces. Okay, but let's continue from here. Let's quickly put the accelerations on here, and then all the image will actually come clear to you. So now we know if I have an object that is going along this collar, at this instant, it will have a reaction force between the collar and the tube along which it's sliding, right? And the other force could be like either a frictional force or it could be a force that's actually pushing this guy along the collar. So we know that for sure. Now, if I actually want to write the accelerations over here, right? What are the accelerations on this object? Like if this is my theta, right, and then this is my r, what do you think are MAs on here? Well, we have two accelerations, right? We have the radial acceleration, which you already described. So this guy is my AR, my heke, and I already know what AR is, right? What is the other acceleration that I have? It is
transverse.
transverse, exactly, which is MA theta, right? So let's actually do this. Okay, so this vector right here is M A theta, ما هيك? And what was AR? I think you all know AR was equal to what? R,
في equation.
exactly, R
prime.
double dot minus R theta prime square. Remember, now AR is pointing outward, right? If you put AR pointing inward, then this would be the opposite of that, right? So AR is equal to this. And then how about A theta is equal to R theta double dot, right? Plus the Coriolis R prime theta prime. Okay, so now we're good. Now we'll assume that we actually know the trajectory of this particle, and then we have AR and A theta. Now what remains is if you actually know AR and A theta, how can we actually solve N and P? So basically, it is just we have to find this angle, right, between N and P, between N and the radial line, right? This is my radial line, right?
Yes.
And this guy is what? My tangent, right? Or this is my tangent line, right? So if I can actually manage to find this angle between N and the radial line, I'll be able to sum the forces along this direction, and then I already have MAR. It's already done. Like I know the mass, and then I know AR. I'll be able to, write that. Okay. So here's the most important thing that I want you guys to learn here is there is one missing angle that is very important for us, and the angle is actually called phi. Okay. And the angle phi is the angle either between the radial line and the tangent on this direction, or it is this angle between the radial line and this tangent. So it's always the radial line and the tangent, right? If it's more than 90 degree, then you will take this. If it's less than 90 degree, then you'll take this, and then you will always put it as your absolute value. Okay. What is phi? Well, tangent of phi is going to be equal to r divided by dr over d theta. Okay. So phi is actually inverse tangent of r dr
إذا
over d.
أعطوني
Yep, it's always like that. Okay. If it was negative, it will be so here there is a rule basically. If it was negative, then uh, if you look here, if phi is positive, it is measured counterclockwise, right, from the radial line. So if it was positive, it's basically measured counterclockwise, and if it was negative, it's measured in that direction. But you don't really need to get stuck on that, right? Just know if phi is less than 90 degree, just take the absolute value of it, and it's going to be here. If it's 70 degree, it's going to be here. If it's greater than 90 degree, right, it will be basically the other one. Okay. Uh, okay. So once
تيجي
you,
given
I'm sorry.
تيجي given هي ما هيك؟
No, you solve for it basically. You solve for phi inverse tangent of r dr over dθ. Now we're gonna do actually an example on that. But this is what I want you guys to know. Once you find phi, right? Let's say phi was this guy was the larger one, right? Then you're gonna put it here, and now you can actually relate all of these, right? So if this is my phi, right, how do you think I can find the angle between n and the radial line? If this guy was my phi, if phi was greater than 90 degree, then this is my phi, right? So I can actually solve for that based on the value of r and d theta at this angle. Okay, well, you know r as a function of theta. After you differentiate r, you do the r as a function of theta. So ultimately phi is a function of theta. ما هيك؟ Phi will vary with theta. So let's say you find phi here. How can you actually find this angle right here? Okay. It's a bit, not much of a geometry here. Well, I basically know that this angle is going to be 90, right? Right? What n basically makes with the tangent is 90. You guys agree? Because I know n is always perpendicular to the tangent. So this angle is going to be phi minus 90. ما هيك؟ هيدا الانجل right here.
فيني انا اجرب.
Uh, Yep, sure. We're gonna do an example, and you're gonna find it's very easy, right? So we already found phi, right? So phi is here. We know n makes a 90-degree angle with the tangent, and then I know this phi is with the radial and the tangent, so I know this guy is gonna be phi minus 90. So that's it. Okay. So now basically I can sum the forces along the radial line. Okay. And if I do
بس هون شو قلنا الفايل الكبيرة أو الصغيرة؟
no the كبيرة هون, we're assuming it's the largest one.
بس كيف خدتها 90 أنت؟ radial line والtangent line؟
No, I'm saying phi is this angle, right? So this is phi right now. Okay, so this is my phi. Okay, and I know
Okay.
n basically makes a 90-degree angle with a tangent line, right? So the normal force makes a 90-degree angle with a tangent line, right? So what actually,
أوكي مش الحال مش.
yep. So what remains is this angle is going to be phi minus 90, and then this angle is right here, phi minus 90, right? So now I can basically sum the forces along the radial line, right? And what do I get? I'm going to get n cosine phi minus 90, right, is going to be equal to what? You basically, you would still, for example, in this case, we would still have P, right? But in general, like, so this angle now here basically is enough to actually project that, okay? To project the normal force on that, all right? And you already have AR and we already have A theta, okay? So just know that this angle phi, right, is the angle between the radial line and the tangent, okay? So let us actually do an example on that, because I think the best way to learn on this is by actually doing an example. Um, Before doing an example, I want to actually do this problem, okay? This is another example basically, which is on a lecture. If
بس
you have,
دكتور قبل
I'm sorry?
الإكزام صار ب 26 أم بعده 23
No, the exam is actually going to move into, we're pushing the exam until the following Monday, basically. I'm going to
أوكي
actually I'm going to send an email to the whole class, basically, shortly after this presentation. Some students emailed me that they cannot make it on Friday or whatever, so we pushed it for a few days. So it will be
deal
the
thank you دكتور.
Yep, it will be the 26th. Okay, so let me just quickly do this example here of this plane executing this loop, right? If I have basically a pilot that is executing this loop, and I know the position of the pilot as a function of theta, right? How can I find, for example, the reaction between the pilot and the seat, right? So the pilot now is sitting, upside down. How can you find that? What we have to do is we have to do a free body diagram on the pilot, and then we have to also do another diagram where we put the inertial force, inertial accelerations. Can you, what do you think are the forces on the pilot, right, when it's executing this maneuver? Well, we have his weight, right? We have his weight, mg, right? And the plane is going to the left, so there must be some force r, right? Okay, even if it's going to the left, r could be the opposite direction, right? Like you could be going to the left direction, but you are decelerating. What is the other force that you think we might have here?
friction resistance.
Air resistance. Well, we're not doing the air resistance right now on the plane. We're only looking for the forces that are on the pilot, right? So R is the force that the seat
في
actually.
normal.
Yeah. So R is the force that the seat applies on the pilot, and we also have N is also the force that the seat applies on the pilot. Does that make sense? Okay. So this pilot is sitting here. He
Okay.
has a weight, and then
On
there's
his back, you mean?
yep, exactly. R on the back, and then N on the bottom, right? Okay, pushing him either up or down. We don't know. So now we just have these two values. And how about on here? What do you think are
بس we said he's sitting upside down. ما لازم تكون بالعكس.
well, the weight doesn't change, ما هيك? R and N are unknown. Like we don't know. Like this is a force by the seat. So either it could be like the seat pushing him forward, مظبوط, or it could be the seat belt, right, decelerating him backward, right? Right? If you're sitting in your car, basically you probably have two forces, right? Either like the seat is pushing you forward, right, or the seat belt, ما هيك, or your hands which are on the wheel are pushing you backward, right, inside the car. Okay, now we're basically isolating the pilot. Now we're doing this free body diagram only on the pilot. How about the accelerations that are subject to the pilot? If you actually look here on a diagram, right, we have theta and then we have R. مظبوط. So we're gonna have what? We're gonna have MAR, right? And then MAR is in a positive direction as R. So this guy is gonna be equal to what? M R theta double dot minus R theta prime square.
R theta. Yes.
Deal.
وهيديك
What else?
perpendicular على اليمين.
Is it to the right or to the left? Is the arrow pointing to the right or to the left?
left لأنه growth تبع theta.
Exactly, bravo. In the growth direction of that. So it's gonna be M R theta double dot plus 2R prime theta prime. Okay, so if I sum the forces in a vertical direction, I'll be able to find N, right? So N minus mg is going to be equal to what?
MG
M R to the
M
there you go. So your N
هوليك equal.
exactly is
R
gonna
equal minus.
so M is the same here. So I'm just gonna do M G plus R to the double dot minus R to the prime square. And notice all of those are actually units of acceleration. ما هيك R double dot is the unit of acceleration. R to the prime square is the unit of acceleration. If R double dot is 0, so N could either be less, مظبوط, or it could be more than the weight of the person, depending on how that actually goes, right? If it was going up, basically N will be less than the weight of the person because you have R to the prime square, مظبوط. So depending on whatever values you actually have here, you will actually control N. And then if you were actually to find R, how would you find R? Simply sum the forces in the left direction. And then we know R is going to be equal to M R to the double dot plus 2R prime to the prime. Okay. So basically this last portion of this chapter is simply about relating the forces and the accelerations, and doesn't really matter how the acceleration like, you just simply have to sum the forces in the same directions. You literally have to sum the forces, and whatever you do on the forces you basically do on the accelerations. And then how many unknowns do I have here? Usually I have two extra unknowns, right? Either R or N. So if I have R and N, I can solve for these accelerations, right? And if I have the accelerations, I will be able to solve for R and N. Okay, so it's a two equation and then two unknown type of a system. Okay, so this kind of is explained here in this presentation, right? Sum the forces in a radial direction, so MAR is equal to this. Summing the forces in a transverse direction, R double dot plus 2R prime to the prime, right? So make sure that the transverse direction, guys, is never the tangent, right? Some people make the silly mistake thinking that that so here it actually looks close, right? But it looks like this guy is actually tangent to the motion, but this guy is not tangent to the motion, right? It's simply perpendicular to this. So make sure you get that right. So if I was actually here, right, then this is going to be my right. This is going to be my transverse, right? A theta. It is always basically perpendicular to the radial line, right? It's not tangent to the path. Okay. Okay, good. So I think we can solve a problem now. So this is what I was describing earlier about the angle phi, right? So the angle phi is angle between the radial line and then the tangent, and then we can use this angle because we want to relate the normal forces or the forces with accelerations, right? And then this comes helpful because I know the normal is always perpendicular to the tangent, right? And I already have the acceleration provided to me in the radial direction. So I need to have a reference between the radial line and the tangent, right? Or to the perpendicular to the tangent where the forces usually live if you have a Kohler type application. So this is a derivation of this guy, right? If you actually move by a bit, you have r d theta on this end, and then this guy will actually increase by dr, right? So tangent phi is nothing but opposite over adjacent, right? So tangent phi is opposite, in this case is r d theta, and then adjacent is dr. So this is really what it is. Okay, so I'm just gonna do one example here, and this is example 8. So we have this arm that is rotating with a rate of so theta prime is equal to how much? 4 radian per second. And we have our acceleration is equal to 3 radian per second square. And theta is equal to 180 degrees. All right. And we need to basically find the force that that the rod basically will exert on a smooth cylinder, right? If it's confined to move along this trajectory. Okay. So this is what I have. I have this. Just bring that here. Okay. Okay, so I have this cylinder right here, right? And then it's being subject to two forces, right? This is in the horizontal plane. And if it's in the horizontal plane, basically, I have no gravity applied on it. So the horizontal, this bar basically, right? The rotating bar basically will apply a force P on it in that direction, right? And as a result of this guy being constrained along this direction, right, it will actually touch on this end, and this is going to be my normal. Okay, and these are the only two forces, right? If this was a vertical plane, that I would basically have to add mg to it, right? All right, now if I actually want to look into the acceleration of it, so I have theta. See how theta is basically, right?
بس ما كثير فهمت ليش ما عندنا MG. ما
What
كثير
is it?
فهمت. Why we don't have MG? ما
Yeah,
كثير
because this whole movement is actually occurring in the horizontal plane. You know what I mean? And it's not vertical, it's horizontal, right? So there is no weight applied. Think of this
Okay,
as
ما
like
في
sitting on a
gravity.
table.
We don't have gravity يعني.
There's no gravity, exactly. So that is why I'm not including here mg. So how about on here, basically, what are the accelerations that I have? Well, I have a transverse, right? Can you tell me how the transverse direction would look like? Transverse inertial force. It is ma theta, right? Right, so it's actually like that, right? So there you go. So m, right? What is my transverse acceleration that we said last time? So m is going to be r theta double dot plus 2 r prime theta prime. Okay. So that is one thing, and then you can see that from the reference frame that we actually have here, right? And then on this side, basically, we have this guy, m r double dot minus r theta prime square. Okay, so we're good here. Basically, what we need to do is we need to find the force, right? P. Okay, but how do I know the force P? Basically, we can solve these based on whatever values that we have, theta prime, theta double dot theta, right?
بس
And
ليش خدنا vertical horizontal؟ ما كثير عم بفهم عليك. ما هلا قلنا انه لازم تكون in the direction of R.
yeah, so this is the direction of R, right? So R basically starts, the origin is basically here, right? And then this guy here all the way is my theta. Okay, so this is my R, and this is the gross direction of theta. Okay, so this is the gross direction of theta, and then this is R. Um, okay, so what I need to do is I need to basically calculate what R double dot, what all these values are, right? And then I need to basically sum the forces, right? And then obtain what the value for P is, right? So I need to know P, so I have to sum the forces along the direction of P, and then I'm gonna have what? P minus, so now I need this angle. What is that angle? If you remember what we just, so I need to actually know this angle, right? Um, and I'm gonna actually call this angle, we need to find that angle. How can I find this angle? I'm gonna actually call it alpha for the time being. Well, we just said that we actually know the angle between the tangent, right? The tangent. This is my tangent line. And the radial line, مظبوط. So we can actually solve phi, right? So if phi is here is less than 90, then it's going to be here. Or if phi is greater than 90, then it's here, right? So I can basically use that to be able to find alpha. So if I sum the forces in the vertical direction, I'm going to add a P, right? Minus N sine alpha, right? Is going to be equal to what? It's going to be equal to this, right? So M R theta double dot plus 2R prime theta prime. ما هيك؟ So هلا we need these values. We need to find theta prime, etc. Theta double dot, and then basically R at that value. Okay, before I do that, let's actually find alpha. To find alpha, we need to find the angle phi, right? So we said phi is either this guy or it is the whole guy, right? So we know tangent phi is equal to what? R over the R d theta. ما هيك؟ So phi is equal to inverse tangent of R over the R d theta. Okay, so what is R? R is actually given to me as 2 over theta. So R is equal to 2 over theta, which is 2 theta minus 1, right? So what is the R d theta? dr d theta is I'm gonna multiply this guy by minus. So minus 2 theta, ما هيك. What is the derivative of this? Minus 2. You agree? Okay, so what is phi then? Then phi is equal to inverse tangent of, what is R? I have it, right? So 2 theta minus 1 divided by the R over the theta, which is minus 2 theta minus 2, right? So 2 and 2 will actually
بس
cancel.
ليه حتى vertical انه مثل الباث تبع التانجنت
Yeah,
او الكيرف يعني.
yeah, like let me just finish this up very quickly because we have 5 minutes left, and then we can open another session just to kind of explain that. But if you watch this very clearly, you will understand exactly how we're actually coming here. So I'll do minus, I have theta minus 1, theta minus 2 تحت, so راح تصير theta, right? But what is theta at the instance where I'm actually finding phi? If you actually look here, what is theta? Theta is actually equal to pi, right? So I'm trying to find this angle phi when theta is equal to pi. Okay, so inverse tangent of minus pi. If you do that, basically, I think you will get something like 72 degrees, right? So a tan d of pi, or a tan pi, is 1.26 radian, radian to degrees. Okay, so it's minus 72 degrees. Okay, so here it's less than 90, ما هيك? Minus 72.3. So it's less than 90. So which angle did I just calculated? I just calculated this angle, ما هيك? So هذا الانجل هون is how much? 72.3 degrees. So what is alpha? Well, I know n is perpendicular to the tangent, so it's going to be 90 minus 72. Okay, so 90 minus 72.3. So this guy is going to be equal to how much? 17.7 degrees. So this angle here is 17.7 degrees. That is that angle. So this is my alpha. Okay. Okay, what is, so we're good here. Okay. Now what I still need is to calculate the rest, right? I need to calculate these guys. So I know P is equal to N sine alpha plus M r theta double dot plus 2r prime theta prime. Okay. So well, what is r? Well, I know r, right? I know theta double dot. All of these are basically provided to us. We still need to actually solve for n. How can I find n? So the way that we can use to find n is we can simply sum the forces in a horizontal direction, and I'm gonna get n, right? If I sum the forces in the horizontal, so n cosine 17.7, right? So n cosine 17.7. So I'm summing them in the right direction. So this guy's gonna be minus, right? Minus m r double dot minus r theta prime square. Okay. Now let's actually put some numbers on here. Well, what is r double dot? Well, I know r is given to me as what is the value for r? Okay, 2 over theta, so 2 theta minus 1. What is r prime? R prime is going to be equal to minus 2 theta minus 2 times theta prime. What is r double dot? R double dot is going to be equal to, so we're going to differentiate this guy one more time, which is equal to what? So minus 2 times minus 2 is going to be 4, right?
Plus
4
4.
times theta minus 3 مظبوط times theta prime square check one as theta prime will come in minus 2 theta minus 2 times theta double dot. Okay, let's rewrite that. So r double dot is actually equal to 4 theta minus 3 theta prime square minus 2 theta minus 2 times theta double dot. Okay, so that's your guy, right? So what is now we can basically replace all of these. So I know n is going to be equal to minus m r double dot, which is this 4 theta minus 3 theta prime square minus 2 theta minus 2 theta double dot minus r. What was r? 2 theta minus 1 times theta prime square. So now you see everything is now known, right? And over show cosine 17.7. What is the value for m? 0.5. M is equal to 0.5 kg. Theta is equal to how much? Pi, مظبوط. What is theta prime? What is theta prime? 4. مش هيك؟ theta double dot is 3. And that's it.
نحل problem كله given.
Exactly. So now we're good. So now we have n. After you have n, you're gonna come back here, right? And then you solve for p. Okay. So p is gonna be equal to n sine alpha plus m r theta double dot plus 2 r prime theta prime. Okay, so we're good. Okay, we've solved n, we know alpha, we know all. Okay, we solved n, we know all these values. So you guys are good here. So I'm not gonna do all these computations here. Just numeric computations, we already have them, right? So we already solved n. We know this guy. We know r is gonna be equal to 2 theta minus 1, where theta is equal to pi. And what is r prime? So we need r prime here. We already solved r prime, right? R prime is equal to what? Minus 2 theta minus 2 theta prime, right? Where we know theta is equal to pi, and then theta prime is given to me as 4 radian per second. So that's it. Okay, so we're done. I'm gonna close this session and I'm gonna open up if you have any more questions. Okay.